In this video, we will work through several exam-style questions on the angle in a semicircle theorem. But first, here is a quick recap of the theorem itself. Here is a circle with centre O. We draw a line AB that passes through O. Line AB is a diameter of the circle. A diameter divides the circle into two semicircles. C is a point on the circle. The angle ACB is called the angle in a semicircle. According to the theorem, the angle in a semicircle is 90 degrees. That is true no matter where C is on the circle. If you would like to try the questions before you see the answers, they are on the Graphic Maths website. There is also a video about the angle in a semicircle theorem on this YouTube channel. There are links to both in the description. Here is the first question. The line ST is a diameter of the circle, and R is a point on the circumference. The angle RTS is 34 degrees. We have to find the angle X. How do we tackle this? It looks like it will probably involve the circle theorems. Since one side of the triangle is the diameter of the circle, this means that the angle SRT is an angle in a semicircle. We know that the angle in a semicircle is 90 degrees, so we can mark SRT as a right angle. We also know that the angles in a triangle add up to 180 degrees. Looking at the triangle SRT, we now know two of the angles are 34 degrees and 90 degrees. The third angle is X, so we know that X plus 34 plus 90 is 180. Solving for X, we have X equals 180 minus 34 minus 90, which is 56. So X is 56 degrees. Just before we look at the next question, if you're enjoying this video, you might like my Circle Theorem workbook. It has more questions and solutions and a handy revision guide. You can get it on Amazon or read it for free on KDP Select. The link is in the description. In this question, the line BC is the diameter of a circle. The diameter is 5. A is a point on the circumference. The line AB has length 3. What is the length X of the line AC? Once again, we are dealing with an angle in a semicircle. The angle BAC is an angle in a semicircle, so we can mark it as a right angle. So ABC is a right angle triangle, and we know the length of two of the sides. We can find the third side using Pythagoras' theorem. Pythagoras tells us that a squared plus b squared equals c squared. In the formula, c is the hypotenuse, which is the side opposite the right angle. This is the diameter BC, length 5. A and B are the other two sides with lengths x and 3. Putting these values into the equation gives x squared plus 3 squared equals 5 squared. Solving for x gives x squared equals 5 squared minus 3 squared, which is equal to 25 minus 9. This means that x squared is 16. Taking the square root of both sides, x is equal to 4. In the next question, ST is a diameter of a circle, and R is a point on the circle. The angle RTS is x, and the angle RST is 5x. We need to find x. Again, we can use the fact that the angle in semicircle SRT is 90 degrees. The three angles in the triangle RTS add up to 180 degrees, so x plus 5x plus 90 equals 180. We can simplify this to give 6x plus 90 equals 180. Solving for x gives 6x equals 90. Dividing both sides by 6 gives the answer x equals 15 degrees. In our final question, VW is the diameter of a circle, and U is a point on the circle. The angles in the triangle are 3y, 5y, and x. At first, this question looks very easy. We know that the angles in the triangle UVW are up to 180 degrees, so we can say that x plus 3y plus 5y equals 180 degrees. This simplifies to x plus 8y equals 180 degrees. But the problem here is that the equation has two variables, x and y, so we can't solve it as it is. But we know that the angle in the semicircle, VUW, is 90 degrees. Since this angle is 5y, we know that 5y is 90 degrees, so y is 90 divided by 5, which is 18 degrees. Now we can substitute this into the previous equation for x plus 8y. This tells us that x plus 8 times 18, which is x plus 144, equals 180 degrees. Solving for x gives 36 degrees. So in this case, x is 36 degrees and y is 18 degrees. If you enjoyed this video, please subscribe or join my Substack newsletter at graphicmaths.substack.com.